Lesson 2 is going to be about direct and inverse proportion, so let's get started. So we're first going to talk about direct proportion, which is probably the most common type you will see. Now, direct proportion is when the quotient is constant. So an example would be like if I have 4 over 2 and then over here x over 8. To solve for x, we would cross multiply. So we have 2x equals 4 times 8 is 32 and x is 16. And x keeps changing so that the quotient remains constant. The quotient is 2, right? Our quotient is 2. And this remains constant as we keep changing the denominator, and the numerator changes accordingly. So if I were to do 4 to 2, and then I put a 4 in the denominator, and then I have an unknown over here, I would do 4 times 4 is 16, and then I put an 8 over here. Every denominator has a corresponding numerator, which is where the quotient remains constant in direct proportion. That's all you gotta know for direct proportion. The quotient remains constant. Now let's talk about inverse proportion. Inverse proportion is a little bit different. It's a little bit more interesting. Suppose that 4 people are capable of running across an entire a large city in 2 hours, right? Or 4 people are capable of cleaning an entire beach in 2 hours. Now, how many people would you expect? 5 people. Or I want to do an easier example. How many people would you expect 8 people to do so? How many hours would this take? Now, inverse proportion, let's try doubling the first value. If we double the value of 4, we get 8. Well, if we're doubling the value of 8, it's just half the work. Now, we already know x is going to be 1, but remember, in inverse proportion, the product remains constant. Now, 4 times 2 is 8. For the product to remain constant, x must be equal to 1. So our answer is 1 hours. And to figure out if a value is inverse proportion or direct proportion, to recognize them in problems, right? Over here, the product's 8, so I'm going to write that. Product's 8. If we double the first value, we doubled 4, we get 8. Think about, is it going to take half the time, or it's going to double as well, right? Here, in this example, we're clearing a beach. It's going to be faster when we have more people, and henceforth, it's going to turn half of 2 is 1. And obviously, it's going to be smaller. X is going to be smaller than 2. It's going to be less than 2, right? So if we double the first value, now check what the corresponding value is. If the corresponding value doubles as well, then you have direct proportion, right? So in this example, right, 4 to 2, if I double some value, like if I double 4, I'm going to get 8, right? If I double 4, I'm going to get 8. Well, let's check this out. Over here, when we have 4 to 2 is x to 8, if we double the value of 4, we're going to get 8 to 2 equals something to 8. And now we have 2x equals 64. Solving, we get x equals 32. And the original value is 16. 16 times 2 is 32. So since the other value doubled, we have direct proportion. Now with inverse proportion, obviously, if we double the first value, we get 8, which is what our example was. But if we double the first value, we get 8. Now the time is cut in half. Since we're clearing a beach, obviously it's going to take half the time. So that's how you recognize inverse and direct proportion in problems. Now let's do 2 problems and see if you can recognize direct proportion versus inverse proportion. 4 people can build 14 cages in 1 day. How many cages can 6 people build in 8 days? Now, I want you to think about the problem for a minute. Think, is it direct proportion or inverse proportion? Now, 4 people can build 14 cages in 1 day. If we double the amount of people and get 8, we'll be able to make more cages, specifically twice as more cages. Now, if the second value doubles, we know that it's going to be direct proportion. Direct proportion. Now, we know 14 cages are built by 4 people in 1 day. But the problem is asking how many cages can 6 people build in 8 days? Well, this is just 1 day. Now, we could do some things, we could multiply by 8, but I'm just going to go simple. This right here, this is the cages. This right here is the people. 4 people, 6 people, x. What I'm doing is I'm finding how many cages can 6 people build in 1 day. We know 4 people can build 14, so 6 people should be able to build more cages. Let's cross multiply. 4 times x, 4x. And now we need to multiply 14 times 6. Easily complete that on the side. 6 times 4 is 24. 6 times 1 is 6. 6 plus 2 is 8, so we get 84. Solving for x, we have 84 divided by 4. Notice that 21 times 4 is 84, so we know x is 21. Now, 21 people, or 6 people can build 21 cages in 1 day. How many cages can 6 people build in 8 days? Well, we just take that. It's going to be 8 times the number of cages they can build in 1 day. So just 21 times 8. Computing this, we have 1 times 8 is 8. 2 times 8 is 16. So 6 people can build 168 cages in 8 days. We're done with this problem. Let's go on to the next problem. 8 people are going shopping. If all 8 people can buy an entire section of the store in 2 hours, how many hours would it take 4 people to buy an entire section of the store? Think. We're dealing with proportion. Is it direct or inverse? Alright. 8 people are going shopping. All 8 people can clear up an entire section of the store in 2 hours. Now, let's double 8. If we have 16 people, obviously we're going to be able to clear the store much faster, right? Since we'll have more manpower to buy more stuff, to clear the entire store quicker. So we're dealing with inverse proportion. Now that we know we're dealing with inverse proportion, let's go accordingly. 8 people can buy an entire section of a store in 2 hours. 8, 2. How many hours would it take 4 people to buy an entire section of a store? Hours is the unknown, and we have 4 people. This is 8 people, 4 people. Hours is unknown, x. We've built our thing. Now, 8 times the product remains constant. Remember, inverse proportion. 8 times 2 is 16. We have a much simpler equation. Solving for x, we get x is equal to 4. So, if we have 4 people, it would take 4 hours to buy an entire section of a store. Right, since we have 8 people, notice how 4 is just 8 divided by 2. So if we cut 8 in half, it should double the amount of time we take. Since we have half less manpower, we should take double the amount of time. That's how our product's going to remain constant. So it would take 4 hours for 4 people to buy an entire section of our store. That's lesson 1. Hopefully this video is helpful. And yeah, that's direct and inverse proportion.